Let's wait to
I just wait to 5:10.
okay, 5:10. Are you okay?
Yeah.
Is it okay for 5:10? Okay, let's just wait to 5:10. Yes, more people joining.
Yeah. And as we wait, like I just wanted to know, is there anything you would like to ask, like so far, something you don't understand? You can just use this few minutes to like try to explain or try to yeah help you understand it better. So Kelvin, Manolo, CC, is there anything you would like to ask so far? Anything you've been confused about? Please just go ahead and ask. Let's see if we can help.
Okay. I think this one is for you, Goswa. Said having issues with struct. Um, have you seen the
Okay,
yeah?
actually, I don't know why.
Have you
Zoom
seen
is
the
a very
comments?
okay. Yeah, having issue with struct. So what part in specifically? How to access elements in a struct and work with it. Um, okay. So far, what I've been using, or what I've seen is using the dot notation. Like, I think that's how it's done, but I think this is quite trivial. So this is probably not what you're asking, but if you can give me more details, I'll probably be able to make more sense of it. Like, can you just like probably just unmute if possible and explain?
Okay, so are you seeing the questions
Yeah,
goes?
yeah, 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 I am. Yeah. So, um, a lot of things are not the same in Cairo Solidity. But yeah, if you want to say, let me just say from like a high level perspective, right? I want to create a struct, or rather, I create a struct called student details, right? It has a name, it has an age, right? Just to name an age, right? And then declare, I create a struct using that blueprint because the way I see structs, they are more like data blueprints, right? They are not data in themselves because they are just saying that every object created with this struct should look like this, right? So now let's say we want to create a struct or a struct data using the struct called student details, right? We add a name and we add an age. Then if you want to get the data, we use let's now say we stored this particular student data that we just created into a variable name called student detail one, right? So if we want to get the students like student details of student detail one, you just do dot name and dot age. Talking from a high level, maybe it's make more sense if I write in code, but this is how it works, and I think this is how it also works in Solidity. But you know that Cairo is very different from Solidity, from the syntax to like it's actually very different. So yeah, some like let's say you might want to declare the variable and like why calling this, right? Calling the individual data of the structure, you might be asked to use something like you might ask to declare the type and stuff like that. Yeah, it will make more sense if you actually convert this to code, but just know that the way I explained it now is more like how it should work. But yeah, code is complex. So in as much as it's very basic, we might write it now and see that this is how it works. But from a high level, this makes sense. Understand? This is how it works in Cairo. It's hard for me to understand how recursion works. Actually, first of all, recursion is not really easy in terms of so I totally understand. Recursion is in itself is not a very easy topic, right? But recursion works just like recursion in Cairo works just like recursion works in any other language, right? Except you want to start going on a lower level, which we don't really even know how that works, right? Most people don't know, like, except you start going through the code on how Cairo was created. But from a high level, recursion, like, I think if you want to, the best way to see recursion is seeing it as not, okay. But if I write, okay, don't worry. I think I'll just go through my code and see an example of structs. Yeah, well, yeah, I'll go through that. But let me just answer Manolo. So for instance now, right, if you write recursion in Python or write recursion in, like, a language should be able to support recursion. I know, like, what happens is if um if a function calls itself at the end and the language supports recursion, then what you think will happen, which means that it will start, like, going through it, incrementing the values, right? So for instance, now if you want to solve a Fibonacci sequence in Python, the same thing you would write in Cairo, if you convert it to the same syntax in Python, it's the same thing you would write, right? Just different syntax. So recursion in itself is not, it's not really, like, it's normal recursion that's happening in other languages. So what will help you understand it better is the fact that recursion is not just like, a language should support recursion. And if a language supports recursion, then it's normal everywhere. So if you understand the one in Python, because of it's an easier language to understand. If you understand the recursion in Python, you should be able to understand the one in Cairo. So I think what will help is probably use a language that is easier to learn it, then just transfer the knowledge. Recursion in itself is a hard thing. Even like, you're just writing it in Cairo syntax. Recursion is not easy. But what helped me understand is that recursion is like a language supports it, because in itself it doesn't really make more sense that, like, if you're going through something, going through it and it will be incremented by itself, but it's because of the language supports it, right? Like, when even till now, I still find Fibonacci sequences really, I find it confusing. Like, even when I'm using Python, because I don't really, well, that's how recursion works, right? The language supports it, and the whole incremental thing and going through itself. That's why you should add terminal conditions so that it should be able to stop, right? So yeah. So basically, I think if you understand recursion in itself and implement it in an easier language, it will help you understand it better. But there's really nothing different about the one in Cairo and the one in other easier languages. Okay, let me see if I can find an example of, okay, let me go through my contracts. Let me go through my contract. Okay, it's almost, okay, it's already 7:10. Well, okay, let me just go through my contract. Yeah, let me go through my contract. I should see a struct.
Okay, so while you go through your contracts, I guess just probably introduce, like, before you get starts the week 5 classes. So glad to have you all here again. It's actually been, okay, today is the week 6 and we have been doing great as well. But then we made some comments about the assignment. I guess probably people were not, like, following up because we didn't give feedbacks, and we're sorry about that. But then feedbacks will be coming in, like, immediately, like within the week after the class is done. Okay, so you get, like, feedbacks immediately, so you know where you should improve. Okay, so today Gospel is going to be talking about Starknet.js, and yeah, I'm looking forward to what it's all about. And Gospel, when you're ready, just start.
Okay, Fifi, like, let me just check this later, right? So I don't, like, deviate, but definitely I would explain this better to you. Yeah, so welcome, guys. Today is okay, let me share my screen quickly. Okay, don't mind me, I'm on Twitter. Let me move to my yeah. Today is we're working on something a bit different, because since the beginning we've been talking about just Cairo. Well, from today, just today we'll be talking about something more on the less technical side and on the front end, right? So we're talking about Starknet.js, right? So Starknet.js is, okay, let me do a bit because I noticed that I've not really been doing introduction of myself, right? I've been starting. So yeah, my name is Gospel Isaac. I'm an engineer, and yeah, I'm experimenting and growing in Cairo. And yeah, so what is Starknet.js? So let me just go to the first slide. You guys can see my screen, right?
Yes.
Yeah.
Yes.
Yeah.
Cool. So basically, we're talking about Starknet.js.
Yes.
And so I'm assuming, I'm like for this class, I'm assuming you have a little bit of understanding of JavaScript. And I can guess that most of you understand JavaScript. I want to just guess because let me just guess. And most people understand JavaScript. So yeah. So yeah, Starknet.js. I'm talking about Starknet.js. We'll be talking about the get-starknet dependency, which is a very important part of what we'll be talking about today and what we'll be building. Then at the end, I would walk you through a full stack application, right? I would walk you through the contract, which might not be necessary, but I would just want to do that for you to understand what I'm working on better. Then I'll take you through the React code. I'll take you through the Starknet.js code. I'll also take you through the contracts, right? Okay, let me just leave that. But basically, we'll be walking through a dApp because you know the real beauty here, but trying to build this thing in real time can easily become a disaster. So yeah, just bear with me. I'll walk you through it rather than building it live. So quickly, let's go to the first slide. Starknet.js is a library for interacting with Starknet, right? Just like Ethers.js and Web3.js. So how I like seeing these things are, right? They abstract the Starknet network, right? So without Starknet.js, right? Without Starknet.js, you probably be writing, let's say using call, I don't know if you know call, CRL, this terminal, this library used to call this in your terminal. I'm probably using it to experiment with, like interact with the Starknet node. So when I say Starknet, I'm talking about a sequencer. So basically a sequencer is more like a Starknet client, right? So what it does is that it stores the states of the Starknet blockchain. So there's a full node which is mainly for data, but there's a sequencer which in transactions sent into Starknet network are being held and stuff like that. So it's more like a client if you want to say it. But if there wasn't a tool like Starknet.js, you probably have to interact with this thing by yourself, right? But what Starknet.js helps you do is that it abstracts a lot of things for you, right? Your contract, your signers, the account and the providers, right? So basically, instead of you to start worrying about how do you send API requests to the Starknet.js node, rather you just use Starknet.js and interact with it directly. Understand? So instead of you saying get this from Starknet, you just use Starknet.js and get these things easily. So I know some of these things already make sense because of if you use Ether.js and Web3.js, you already understand what I'm saying, but I just want to make it make more sense because we don't really talk about that part. Even we just say Ether.js is a library for interacting with the Ethereum blockchain, but what it does basically is it abstracts a lot of things for you, and it's actually a lifesaver because development would have been much more harder without all these tools, right? So I said here provides an abstraction on top of Starknet, right? So we have an account which we've discussed from the first class, which we said that on Starknet we don't have accounts generically inbuilt into the Starknet blockchain or the Starknet network. Rather, we use account abstraction, which simply means that accounts are contracts, right? So like I said in the first class, on Ethereum blockchain, accounts are contract accounts and EOAs, right? But here we use contract as accounts, and this opens a whole lot of possibilities, right? Using a lot of things that you would not normally use, right? So you can do a couple of other things like you cannot normally do using just an EOA, right? So yeah, then a provider, which I'll talk about. Okay, let me just go to the next slide because I talked a bit more on them, right? So providers, I say main objects in Starknet.js. So basically, Starknet.js abstract these things and bundle them into objects, right? So provider is an object, contract is an object, signer is an object, right? Account is also an object, but I just use this main tree here because if you understand this tree, the account is actually not hard to understand. So basically a provider, so most times when you hear provider, you think of URLs, right? You think of URLs like, for instance, now Infura is a provider on Ethereum. I think Infura also provides you with Starknet URLs for mainnet, right? So yeah, it represents the connection to the Starknet, to Starknet and necessary methods, right? So basically, instead of just allowing you to do these things yourself, it represents the connection. It abstracts, it basically gives you an object on top of the network. So it gives you methods to get the chain ID, let's say get the timestamp, get a couple of things, right? Just think about, okay, if you want to get, let's say, if there was an idea of mempool, right? So I don't think they have something like that on Starknet, but if there was something like a mempool, you'd probably be able to get all the current transactions in the mempool using a provider, right? Just like it's done on Ethereum blockchain. So yeah, it provides us method, it abstracts it and just gives us method to interact with these things. And yeah, so basically that was what the provider does. Then a contract is an abstraction of a Starknet contract, right? So just like I said before, that if there were no tools like Starknet.js, we'll probably start using call to talk to our contract, all right, or using a more complex tool to interact with our contract on the Starknet blockchain. But right now, we just have a contract object passing the API, passing some other necessary details, and boom, we have methods to call each functions in that contract. So basically, this contract is an object that's on top of the Starknet contract, and it just helps us do a lot of things that would normally normally find it hard to do, right? So yeah, then the last one here, which is signers. Signers basically it's an account, right? It's an account because basically it helps us to sign transactions, right? So in as much as accounts on Starknet are not native, meaning that they are not built into the blockchain, into the Starknet network, you have to sign transactions, right? So basically, this signer object is an abstraction on top of a signer on Starknet, right? It's a signer on top of Starknet. So then we go to the next slide, which is the get-starknet dependency. So basically, this is another library, but what it helps us do is it helps us connect. It provides us with a model, as we'll see quickly. I would go through the code right now because if you notice, this slide is very short. This is a more practical class than this theory, but I just thought, yeah, it would be nice for you to just talk about these things, right? So provides us with a model, and provides us with the model and methods to easily connect and interact with browser wallets like agents and bravos, right? So if you want to build dApps, you can't just because like connection to agent and bravos is the same thing is similar to connecting to a provider, right? But if you want to build an application that your users will interact with, you can't use you can't depend on your own. You need to have a way to get the user account so that the user can perform transactions in their name, right? So if you want to do that, you can't just use your own account, or you can't tell users to paste their private key. So you can now create a provider object for them or a signer object, right? Because an account is basically the combination of these two, which you would see if you go through the doc. But an account is basically a combination of a signer and a provider, right? Because we assume that like here, so this agent, right? This agent or Bravo's wallet is basically a combination of this provider, which is what agent already provides you, or Bravos already provides you, and a signer, which is what they do it in an interactive way, right? So basically, they are giving you a signer and a provider, right? So if you were building an application that let's say that runs a script, you can just decide to use Starknet.js and run your code on your own server and stuff. But when you want users to interact with it, you need to allow them to connect their wallet, and that's where get-starknet comes in, right? So it does that really well. It provides us with a model that is really helpful. Actually, when I saw the model, like I was just so surprised because it's like a game changer. But it was really nice. And there are a couple of things like that on Ethereum, but seeing that for Starknet really saved me a lot of time. So that's that on the slides. Let me start sharing my share my screen for the demo. So at this point, please, do you have any questions? Ask. Oh, actually, you can see both my screens. Okay. Oh, I didn't know. I thought you were only seeing my Chrome. Okay. Let me stop sharing and okay.
Hi, Gospa, can you hear me?
Yeah, I can hear you.
Yeah, so I have a question.
All right, please
For
go ahead.
building on Ethereum to get a contract instance and like you can perform like read transaction and also like write transactions. When you're doing
Okay.
a read transaction, you're using your provider because you're reading
Okay.
data. When you're doing like a write transaction, you're using your signer. So
Okay.
is it like still the same concept? Because I didn't really like get the explanation you made on both that provider in relative to like
Yeah.
Starknet.
So every single thing you know about provider signers and contract on Ethereum is transferable here. Yeah, I know the idea when I said provider plus signer is an account or it's an agent is like agent. It was not really, it's a bit confusing. But yeah, just know that what provider is doing on Ethereum is the same thing they do here. The signer here, because a signer is local, right? A signer is not necessarily connected to the internet. A signer might just be because a lot of all this signing of transaction is not done on chain, it's done off chain, right? So a signer is local, but a provider, it's a connection to a blockchain. So when you combine the two, you have a signer who is connected to the internet, and that's what agent is. Agent is a signer, and it's in itself, it can sign transactions for you. At the same time, you can use it to like make read transactions, right? As you'd see. So that's what I was trying to say. Does that make sense?
Yes. So I don't know if you've like talked about this too. So to like let's say initialize your contract on Ethereum, you need your contract API, you need your contract address, and also the signer or provider. So do you still like do something
Yes,
like
yes.
API?
We actually do something almost exactly like that. We use our API, we use our provider to instantiate contracts.
Okay.
Yeah.
Please, it would
So
be nice if you can like share resources like for this front end because that is like my own area of interest.
okay, first off, there's a material on the curriculum, which is a guide prepared by Darlington, and it was really helpful. So you can also, I think it's on the curriculum board, so you can check that out. But I would also share this repo so you can go through the code firsthand and see, because there are not a lot of materials other than like there are not a lot of materials on using in creating full stack dApps. But if you read what Darlington wrote about this, and also if you go through this repo, the repo for this class, you should be able to understand to a good extent.
I think it's a good opportunity to create materials then.
Hmm?
I said
Yeah,
it's like an
actually,
opportunity to create materials.
yeah. I'm looking forward to that. Please do, please.
All right.
All right. Yeah, let me share my screen. Oh, I want to be able to display the application and at the same time share my code. Okay. Okay, let me just first of all show you the application I'll be walking through, then I would go back to my code. Just give me a second. Let me run the application then. Okay, let me share. Yeah, so can you guys see this screen? The browser, Power token. Hmm? Can you hear me?
See? Yes.
Yeah.
I see you. I see.
Yes, I can hear you.
All right, cool. So let me just do a quick walkthrough of how this application works. So basically, I created the token, and yeah, my name is Gospel. I made the Gospel as a token. So yeah, it's not live, it's not anything. So don't worry. But yeah, basically, it's just a simple application. You can connect your wallet. So yeah, this is the model that Starknet's dependency provides us, which is really nice, right? If you have a wallet, it just list it here. Okay, it just tells you to, if I click on this now, my browsers will pop up. Then I don't have agent on this browser, so I would have to, it's telling me to install it. And if I click here, it's taking me to the web store on Chrome to download this Agent X wallet plugin. So this is really nice, right? So yeah, so if I clicked on, if I click on Bravos, it pops up. Oh damn, it doesn't show there. Wow. So you know the way MetaMask pops up, that's how it just popped up now, but I noticed it didn't show the recording ball. Yeah, but basically that's how it works. So let me connect so you can see it will get my address and display it on the screen. So yeah, as you can see now, it now has a shortened version of my address. So basically I've connected and it shows that I have 0G token, which yeah, I have not sent anyone to this address. And I think this contract is built on the main Starknet query testnet, which is really unusable right now. At least the last time I checked, it was really, really slow. And so I don't think I'll be able to really interact with this, but yeah, so I just created simple forms to interact with the function. So there's, as ERC20 token works. Okay, that way it should show. Yeah. I'll try that. I'll try that next time. Yeah, so basically you can mint, you can transfer, you can approve. So I'm assuming that you understand how ERC20 tokens work, but don't worry, I'll still go through the contracts for that. So yeah, this is the application we'll be walking through. If I click on this, so when I say, let me try what Darlington said so I can show you how it pops up. So now I'm sharing the whole desktop. So if I try this, which is I'm trying to mint, if I click on mint, you see it pops up, right? So they're telling me estimation. I don't have, they're telling me it's going to fail, which yes, because first of all, I don't have this mint, I don't have this token, right? And yeah, it's actually going to fail. I don't have it here. So yeah, basically that's how it works. Right, so let's just go straight to the code. But at the end of this class, I'll share the full repo for the contract and this front end so everybody can go through it.
So it's going to fail because you don't have the funds to pay for gas, right?
Yes, it won't even send because I don't have, yeah, it won't send.
Okay.
Yeah, so let me share my VS Code and let's just talk about code. So yeah, cool. So first off, I want to go through First of all, I want to go through the contract. Then I'll quickly go through the contract because that's not like the main, but yeah, I'll try to explain as much as possible. Then I would go through the front end, which is the most important for today. So yeah, this is a repo containing the contract and the front end. So let me just go through the contract quickly. So we have, this is a token. This is an ERC20 token, and this is the way I did it. I used the namespace. And basically I define the storage variables in here, and also the necessary functions. Then I call them inside of here. So let's go through. Can you, is this clear enough? Can you, okay, I'll do that. Yeah. Is this better?
Yeah, it's clear.
It's actually clear, but then if you can do full screen too, that won't be bad.
What about this? Because
Okay,
I'm on a wide, I'm on a
this is
monitor,
nice.
so I don't really, it's, I don't know, I'm trying to.
No, this is nice. This is nice.
Okay, cool. So yeah, so basically, the idea of inheritance doesn't really apply in Cairo, right? But we fall back more on composability, which is basically breaking things down, right? So that is one thing. So if this was Solidity, you probably just write an ERC20 function, sorry, an ERC20 contract, then inherit most of the functions on your own. Like inherit most of the functions inside of your own implementation, say your own token, right? But yeah, basically, I just write most of this here so that I can pick them and I can reuse them, not really inherit, but I can just reuse them, right? So basically, let me just quickly go through this. So this is a library. I'm calling the necessary functions. Rather, I'm importing the necessary functions. So get caller address. This basically helps us get the current caller, the block timestamp, get contract address. So yeah, this gets the caller, this gets the block timestamp, and this gets the address of the current contract, right? So yeah, this is for a butane, right? Yeah, hash butane is for a butane, right? So then this is a set not zero. I think the name is quite explanatory. You said that a value is not zero. I said that a value is less than. Then this is true or false, right? And which we know is 0 and 1, because there's no really, their booleans are not native to Cairo. So yeah. So these are functions that are necessary for this ERC20. So the way ERC20 work in Cairo, or rather the way it was implemented by OpenZeppelin, and we know OpenZeppelin is an authority when it comes to things like this. So yeah, it's what most people use for implementing ERC20 tokens on Cairo. So basically how it works is we use a struct, right? I would have loved to open this here, but I'll have to go to GitHub, so I don't want to do that here. So, but yeah, I think I wish this was like a node mode. I'll just open it in the side. But yeah, this is a struct which has a low value and a high value, and low and high, and each of them are 128. I meant to 128 bits. And most times, or rather, what is mostly done is you use the low is the main value, right? The low is the main value, while the high is more like, I don't really understand that concept, because I would normally think that high would be like the main value, but here low is the main value, then high is like the lower bound, and low is the higher bound. That's the right word to use. So more like if I wanted to create a token of total supply of 1 million, high will have a value of 0 and low will have a value of 1 million. That's like a way to see it, right? So yeah, these are utility functions, basically functions that helps us work with this. So checks that this is a good UI 256 function, sorry, U256 struct, checks it compares, and this just like, yeah, these are just utility function that helps us work better. Then this safe is more like a safe version of this. So if you remember if you remember the safe math function in Solidity, which is now no more necessary because of in Solidity 0.8, we no more have to use add because overflow and underflow checks are now done natively. But yeah, what they do is that they help us avoid overflow and underflow in Solidity. But here, they help us perform calculations without the whole checking. Because if we actually just use this, like try to add two values, like say, because there's a function like uint256 underscore add, right? If we use that function and try to add two uint256 values, right, we'll have to also do a check under that to make sure that it's the right value. But using this safe, we don't have to do that. It does that inside of the function. Yeah, and then just drop a good explanation of uint256. Yeah. Okay. Yeah. So yeah, then this uint8 marks. Okay. Okay. What do you see this? Let them use this in the you see me use this during the code out. That would help you understand it better. So yeah, let's go through the code. So these are events. These are events. We've actually looked at how events are declared in Cairo. So these are events, transfer events, and approve events, exactly the same way it's used in ERC20 tokens in Solidity, which is basically they are emitted when a transfer is a transfer occurs, and these are emitted, or this is emitted when an approval occurs, right? So yeah. Then these are storage variables. These are storage variables that would be using throughout this code. So this is the name function, which is the name variable. The name variable, which stores the name of the ERC20 token. So basically, the reason why I'm doing this walkthrough is so that if you don't understand how ERC20 token works, this will help you understand it, and it will help us understand the whole code generally. Yeah. So then we have the symbol, which is the symbol of the ERC20 token. We have the decimals, total supply, balances, allowances. Yeah. So these are just native ERC20 variables that we normally use, right? So this is a namespace, right? So basically, this is more like, I like to see this as this looks more like a class, because basically we are creating functions that we can easily call under this name, right? And you see me use this inside of this G token, right? So basically, we are creating these functions under this namespace, right? So that we can easily get any of this by interacting with this, right? So this is an initializer, right? So basically, we can see in it, like in Solidity, most times when you use an initializer, it basically means that you're working with upgradable contracts, right? Because in Solidity, the name constructor, the function constructor, it works like how constructors work in most languages, which is the function that is called when a contract is being deployed, or rather a function that is called when an object is being instantiated, right? So, but here, because of it doesn't have those, like now here, initializer is just a normal function, just like constructor is like, even if you name a function constructor, it's still a normal function unless you add the constructor decorator, right? The constructor decorator. So basically, this is just like any other function, but from the name, we can easily assume that it's going to be used similarly to how initializers are used in Solidity, which is they are mostly used when you're working with upgradable contracts, right? Then constructor variables the constructor functions are being used when you're working with just normal contracts are not upgradable, right? So this initializer function, let's just see it as normal functions, right? So basically, they do every single thing that we need to do when we're creating a contract, creating an ERC20 token. They define the name, they define the symbol, they define the decimal, right? So yeah, so basically, this value that was imported here, basically it tells us that, like, it actually checks that the decimal we're providing doesn't pass this value, right? So if you remember, this is more like this we talked about it previously, which is more like require and Solidity. So basically, if this fails, this is the error that will be thrown, right? So basically, it shouldn't pass this. Based on OpenZeppelin's implementation, I really don't know exactly why, but basically, it shouldn't pass the highest. It shouldn't pass 2 raised to power 8, which is the highest value that unit 8 can contain, right? Yeah. Okay, unit 8, 2 raised to power 8 minus 1, I think. But yeah, basically, it shouldn't pass this, the highest value that unit 8, the highest value for unit 8, right? So basically, this just checks that and throws an error if it does. All right, so this is decimal, right? It's decimal. So basically, this writes to storage. We've talked about this previously, right? Now, this is the name function, which basically reads the name, which is this name, right? So this is a function that just basically calls from storage. It reads from storage, and this is a read function. It doesn't change state, it just gets data for us, right? So yeah, this is the name function. The same thing here, this is the symbol, just read the symbol. This reads the total supply. This reads the decimal, right? And note, these are all internal, right? Because we are not making any of them external. We're not adding the view. We are not adding. Sorry, my Siri is interrupting. Sorry. So yeah, these are just normal functions. They're internal function, if you like to call them that. Yeah, they're internal functions because they are like, we don't use view, we don't use external, so they're just functions that we intend to use elsewhere, right? We don't intend to deploy this the way they are. We intend to use them elsewhere. That's why I use them inside of this G_ token. So yeah, this is the balance of. So all these are read from here. They are just read functions, so we know they don't change states. This is the allowance. Basically, the way allowance works in Solidity or in ERC20 tokens, which basically these we actually use them to get the spenders. That, for instance, now if you make a Uniswap a spender of your token, right? So this is what is used to check if we actually like how many tokens we are allowing Uniswap to be able to spend. So that's how it works in here. Like that's the idea in ERC20 tokens. Basically, a spender is a person, is an address or a protocol. Most times a protocol or a DEX. In fact, a DEX most times that we are given the code right to actually spend our token. So basically, this actually checks how many is still allowed. You understand? So they are actually still DEXs in Starknet. So just the same idea, right? So yeah, transfer function. So I think this is the first change transaction that changes states. Or sorry, this is the first function that changes states here, which is the way transfer works in normal Solidity. Sorry, rather in normal ERC20 tokens, right? So this gets the caller, right? This gets the caller, and it passes into this order transfer function. So basically, in as much as here, the idea of internal functions are kind of native. You don't have, but they're just trying to make it look like what it would normally look like, because in Solidity they would just create another a transfer function with this underscore in front of it, then add an internal modifier, right? Understand? An internal modifier, yeah, internal modifier. Yeah, so like when I say modifier, I'm talking about, I know there are custom modifiers, which is one we declare by ourselves, like the popular only one we normally use, but I'm talking about modifiers like internal, external, public, and view, right? So yeah, you might not normally call them modifier, but I think when you connect the dots, you understand that modifiers in Solidity work similarly to how decorators work. So they just alter the way something normally works, right? So yeah, normally this would have an internal modifier in Solidity, you understand? So basically, they are trying to make it look like we are talking to a function that is deeper, or rather internal, right? So yeah, this function is declared below, right? So yeah, then this is transfer from basically, this is the way it works normally is that this transfer from is what you would normally use to transfer yourself. Then this transfer function is what you normally use to transfer yourself. Then the transfer from is what a spender would use. Say let's say Uniswap, right? So this check should be done, right? You should make sure that you Uniswap should be able to spend the amount of token they want to spend, right? So I know we are not really talking about React tokens today, but since this is a Cairo class, I just wanted to use this opportunity to explain this contract from a high level, right? So I know I'm not really going deep, but I'm just going through it. So pardon me if you already don't know all these things. I'm just trying to carry everybody along, right? So yeah, this is the approve function. Basically, the way it works exactly the way approve functions normally work. So basically, you're telling Uniswap or you're telling PancakeSwap or you're telling any DEX, that they should be able to spend X amount of your token, right? And the more they spend, the more it is reduced. Then if you come here, you approve again, right? You approve again and so on and so forth, right? So yeah, here you can increase the amount of token you want them to spend. You can decrease the amount of token you want them to spend, right? So yeah, like I said, they used because basically this what I implemented here is basically almost exactly the way it is done with OpenZep. In fact, actually, I think I copied most of the code. Yeah. So now they just used a comment to say that these are internal functions, but basically these two functions are actually the same from a code perspective, but from a readability perspective, they just want you to understand that these are meant to work like internal functions. That's why they're adding this underscore in front, like they would normally add in Solidity, right? So this underscore here doesn't change how this works under the hood, right? It's just this function and this function, they're actually like the same in terms of what they are, right? Whether they're internal or external, they're all internal functions natively. So yeah, this is a mint function which works exactly the way mint works. It creates tokens out of thin air, right? So just generate tokens and adds it to the total supply, right? So this is transfer from, we talk the transfer function that everybody's calling above, right? So yeah. So that's it. So this approve function, it is used in the approve function above. The same thing here, spend allowance. So that's all on how an ERC20 token should look in Cairo or on Cairo or using Cairo. So this is just me now using each of these functions that have already been declared, right? So here's my constructor. So like I said, in Cairo, this constructor is just a normal name, but if you do this in Solidity, you just have a constructor like it's normally used in other languages, which is a function that is being called when an object is instantiated, right? So this decorator just makes it make sense, right? So just you understand that here a lot of decisions are made from a readability perspective so that you understand it. So you can easily transfer the way you see things in other languages into this one without actually creating much confusion, right? So they've just decided to use another name here and still come and add this keyword. And it's actually correct, right? But so that you understand that it's actually the way you see constructors, they just use the same name. It's not like this name changes how these functions work, this function work in any way. You just add this thing here. Yeah, so basically, I'm just now calling each of these functions that are already declared here. So basically now I'm adding the view decorator, which makes this a view function. It doesn't change state. The same thing, symbol, decimal, total supply, allowance, right? They are all view functions, right? And like I said here, they are getter functions, which are basically functions that don't change state. They just get data, right? So they're not really, if you call them, they don't cause gas. They just give you data, right? So yeah, so these are the functions that change state. So basically, I'm just calling all the functions. So remember I talked about namespace, right? So now I imported this namespace here. I imported this namespace here from here. So I just use it just like I would use, say, a class, right? Or yeah, I would use a contract if I wanted to call functions inside of a contract, right? So that's how I'm using them here, right? So this is the transfer function, the transfer from, approve, and so on and so forth, right? So I added a mint function here so that people can mint tokens for testing. That's why you have that first mint button and stuff. Yeah, so that's all on the contract. So you can go through it. But now let's go through the main thing for today, which is how to interact with this contract using Starknet, using Starknet.js and get-starknet, right? So this is a React project. So pardon me, but I'm also assuming, because I would, if I start explaining React, take a long time. So I'm also assuming that you understand React a bit. But to be honest, most of what I'll explain are just like normal JavaScript, and you don't have to understand React to understand it. But I'm assuming that you would understand React a bit. But if you don't understand it, just trust me, you can still follow along really well. So yeah, let me go through where the whole thing is happening. Right. So what you need here out of all these files is just this app.js, or rather what you need to understand, or what I need to explain is just this app.js and this token. So basically, let me just go through this first. This token ABI is an ABI, right? So Kelvin asks if we use ABIs to instantiate contract just like we did Solidity, and the answer is yes. This is an ABI, and I would use it to interact with this my contracts that I've already deployed. Right, so I already compiled this, and this is the ABI, and this is what I'm going to be using to interact with my contract, right? So yeah, this is an ABI. So the same way you use ABI in Solidity, right? The same way you use the ABI to interact in Ethers.js and Web3.js, it's the same way you would use it here, right? So yeah, let me go through app.js, right? So I would have to collapse a lot of this so they don't okay, let me just collapse most of this so they're not too much for your eyes. Let me go. I just want to talk about the main functions because a lot of all these functions help me to interact with the buttons and stuff like that. So just pardon me while I collapse all this. Yeah, so this is the main function we'll be talking about. Okay, yeah. So okay, okay, let me not collapse this. So yeah, this is the app.js, which if you understand React, you know that this is where the whole thing happens in React. Every single thing, like the main stuff, right? Not every single thing. The main stuff happen in React, right? So yeah, this first one here, this is Chakra UI, which is which is what helped me build all these buttons, so you don't have to bother about this. But yeah, if you go through the code, you can search about Chakra UI. It's a really cool library, a library for easily spinning up like UIs if you are like me that don't really like designing anything. Yeah, so this is normal React stuff. Use status effect. If you don't understand it, no problem. Yeah, so basically this is a connect function, which is what get-starknet provides to us to be able to get that model that I used. So when you use this function, right, as you see below, you'll be able to spin up that model, right, and also connect. And it's really nice because after the connection, it now gives you a couple of data, gives you a couple of methods to now do more interaction, right, as you want. So it's really, really nice, but we'll get to that, right? So this is the contract that I told you guys about. So basically, right, out of the main object I told you that Starknet.js provides you with, this is what I'll be using today, right? So by now, probably you would have figured out, but the provider and signer already comes with get-starknet, right? Because that's what Agent is. Agent and Bravos, which are browser wallets, they combine signers. They are like signers and providers combined together. So that's why I'm just using contract here, right? Instead of having to import providers and signers and having to do those things myself, right? So once you connect to Agent, you already have a provider, you have a signer, you have an account, right? So that's why get-starknet is really, really nice. Plus the model, wow, I actually love that model because like having to build, I don't know why, probably because I don't like designs, but I just kind of in my head assume that models are really hard to build. So yeah, these are utility functions which we use below. So basically this changes a value to hex, and this changes a value from hex to string. But yeah, we'll get to that. So you don't have to really bother about that much, but we'll get to that. So yeah, this is the big number library, big number objects that comes with React.js. So I use it for something. So yeah, so the way big numbers work is that in JavaScript, there's a maximum value that you can have. So if you've been working with Solidity, you probably already understand this. Or if you're working with Solidity, or you've been interacting with Solidity contract from JavaScript, you would have understood this because a lot of value is coming from the blockchain at big numbers, right? So basically, the way this works is that in JavaScript, you have a maximum value of integer you can take, and if it passes that, you get an error, right? So if you just go to your browser and type number dot max precision, I think max num, you get the highest value. So if you get a value higher than that, it throws an error, right? So basically, these libraries helps us to deal with these numbers because you definitely would deal with big numbers when you're working with the blockchain, right? So yeah, this big number comes with Ethers.js. Then this one is also a big number library, but everybody implements it the way they want to. So basically, I use these two for two different things. So yeah. So yeah, this is just a utility function I built, address truncator. Forget the big name. Is what helped me to make my address 8 digits instead of having the whole 66 digits that's an address. I think yeah, a Cairo address is like 66 like 66 characters. That's the word, right? So yeah, so this is just a function I wrote to help me make it like 8 values because I want to show it on the front end, right? So yeah, this is the ABI I imported. This is, like I said, another big number library to interact with big numbers, because the reason why I'm having to use 2 big number libraries is because I call the big number library. Okay, here let me just go to the library, please. Let me just go to the library. So the reason why I'm doing it is because the way Ethers.js returns big numbers, or rather, yeah, the way Ethers.js returns big numbers is not the same way Starknet.js does it. So they use bn.js, why Ethers use big number.js or their own implementation of big number. So yeah, that's that. So this is my ABI. I just I got it as a JSON file, then I added it to this. Yeah, I actually said that the way Starknet.js does it is that they use bn, which is another big number library. And if you're using Starknet.js and you get your data, it will return it in the way that bn.js implements theirs, right? But there's something I would actually show you what I needed. Like, it's currently on the screen, but I'll explain why I needed big number, which in fact, like, it's not like you need this, but I used it for something. So yeah, if the way Starknet just returns it is they use bn, right? But why Ethers use big number? So yeah, it's not like it doesn't have a way to work with big number. So actually, the way these things work is, abstraction actually because of they've abstracted a lot of things, right? We now attach things that are not really together. For instance, now, if you're looking for an implementation, like these libraries are opinionated, like they are free to use any implementation they want. So Ethers here use big number, Starknet here use bn. So it's now you that will now decide, okay, how do I want to pass this value? How do I want to decode this value to fit into what you want? That's why I'm using big number from Ethers.js. So yeah, I hope that makes sense. So yeah, this is the
Sorry, quick question.
all right.
So if I understand correctly now, like, sorry, I have to like revert back to Ethereum as
Yeah,
an
no
example.
problem.
So
No problem.
Ethereum like returns big number like in X, right? And you use it as to like format um, those data you're getting in a readable format for users. So like, is it like different? In what form is it the
Sorry,
data
sorry,
coming
sorry.
from?
Sorry, I was a
Can
bit
you?
distracted while you were asking. Can you go over it again, please?
All
Pardon
right.
me.
So, like, if you're reading data from the blockchain now in terms of
Okay,
Ethereum, you're
okay.
returning it in X, right? And Ethers.js has provided like hooks, like utility functions you can use to like format those data into readable formats for users.
Yeah.
So based on the contract abstraction and like the whole abstraction thing is being done by Starknet, is it any different? Is it still like, is Starknet returning data as X or is different?
So first of all, you wouldn't really notice those because Starknet.js just gives you what you can use. You understand?
Okay.
But there shouldn't be really any change in terms of what is returned. It should, like, because of, like I said, you are not really interacting with the Starknet network on your own. You are using these libraries. The way they return in most times is actually better than what you would normally see. So I don't really know what exactly Starknet network is returning to Starknet.js that they are now giving me what they are giving me, but I feel like just using Starknet.js is like what they give you is
Yeah.
good enough.
Yeah, I guess I'll have to like explore it on my own then.
All right, yeah, cool. So yeah, so let's go ahead. So basically, okay, yeah. So this is, if you read the comment, this is token, this is the token decimal with using the big number library for metas.js. So yeah, this is why I use big number. I think I would also use it somewhere down here. You understand better why I used it. Okay. Yeah. So yeah, then I did the same thing. I did the same thing using BN, right? So this is what I was explaining. So this is BN's own. This is the way to declare a big number on using BN, and this is the way to declare a big number using big number from metas.js, right? So this is just two different. I'm trying to represent. I think this is 1 million. Yes, I think this is 1 million. Yeah, I think this is 1 million. So you know, when you're doing ER20, you need to add wait, you need to increment it by the decimal. You need to, okay, basically, okay, this is 18, right? This is 18 million. Is it 18 million? Sorry, this is not 18 million, like 1 raised to power 18. Yeah, this is 1 raised to power 18. I know you can't really use this in JavaScript, like I said, in the big number thing, the precision thing, right? So you can't really use that. So the way I did it here, I just used the two because of I want to. I just declared the two using the two library because I want to use them for something. And you would actually see where I used it below. So yeah, let's go ahead. Yeah, then this is basically, I don't know why I did this, but yeah, I just did 0 multiplied by, this is just basically 0 multiplied by decimal, right? This is just 0. But yeah, this is 0 multiplied by decimal. I don't know why I actually did this, looking at it now. I just multiply 0 in big number times this decimal, which is just 0. But yeah. So let's go ahead. So let me first go through the connect, because I want to show you how you connect the wallets, because a lot of these things here are basically my own way of doing. So this is not really about Starknet. So all these state things, so that's why I'll not really explain the states and stuff, but they are native to React, and I'm just using it to make my Starknet application work. But yeah, let me just explain how the whole connection thing works, and you would now understand that it works almost exactly the way you would normally use, say, the way you would use ether.js to make your MetaMask pop up, right? So first of all, we have this connect function, which basically, so what this does, this await connects, it brings up that model, right? So this is what actually makes the model pop up, right? This is what actually makes the model pop up. When the model pops up, here I'm checking if you actually connected it, right? So after the, it's an asynchronous function. So basically it's waiting depending on what I do. If I click on connect agent, no problem. It says that this is connected, or if I just cancel it or I don't do anything, then this doesn't give anything. So right. So yeah, this now I check because it's other probability that you would connect. So I can't just go ahead and start using these methods like you actually connected. So I have to make sure that you connected, right? So basically, just going to check if you've connected it, right? So then I'll enable it, right? Which is the whole approve part. And like saying that, okay, you want to connect your Bravos or your agents to your Bravos wallet or your agent wallet to the application, right? So Starknet version v4. So actually, I think this is just a version thing because I just got this exactly the way it was done on Darlington's guides. But yeah, basically this is just the version of Starknet you're working with, and yeah, that makes sense. So yeah, all these. So basically, when I wait for this and it's connected, then I now have a couple of data that's now been tied to this this variable, right? So I now have an account, I have an account, and I have an address. Okay, I set connected to true. I guess this makes sense. Basically, I'm saying that my application is now connected and I can now change things. You understand how we do things in React and just be changing the application the way it's based on state variables changing, right? So yeah, this is where I use the truncated address, which is basically what I talked about. I just made my address smaller so I can show it on the front end. And yeah, this is just what would happen if you actually did not connect your wallet, right? So the next thing I want to show you is how I instantiated the contract, which is something really, really important. So let me look for that. Okay, I think I use it in use effect. Yeah, I use it in use effect. Good. So now what I'm doing here is, the way use effect works is it's if you want to update, like the way use effect works is if you want to update the React DOM anytime a variable changes or state changes, you will just do use effects and pass in the data here, right? The variable here, right? So if you don't put anything there, this re-renders anytime anytime you refresh the application, right? But when you once you just put in this, you don't leave refreshes when this state variable changes, right? So basically what I did here is if the account changes, I check that it is not empty, which means that someone has actually connected. Because if someone has not connected, maybe just like, yeah, basically I'm just trying to be safe. So I'm actually checking that. Because if, for instance, now this was an actual value and you change and you disconnect, this would be called, right? Because you have actually changed accounts, right? But I have to check that you actually connected, not disconnect, right? So that I can now update my state. Understand? So basically, now this is that contract object that was provided by Starknet, right? So basically, the way as Kelvin asked, I passed in my ABI, I passed in my contract address, and I passed in an account. So if you understand the way it's being done in React.js, you understand that it's almost the same because what we would normally pass in here is a provider, right? But now I'm telling you that a provider here is a combination of a provider and a signer. And a signer, right? A provider is a combination of a provider and a signer, right? If you combine these two, you have Bravos, you have agents, right? And this was the account that was provided to us here when we connected the wallets, right? So I guess this makes sense, right? So this account was provided for us using set accounts. If you understand how React works, basically this is a state. So this is where this is its set account. So when this account changed, I set the new account, and this is where I set the new account. And this new account is what agents and what get-starknet provided for us. And now I've added the account to state. So here, I pass in the accounts here as a provider, right? So it's not just a provider, it's provider plus signer, understand? So yeah, then I set the contract, right? So now let me now show you how it is being called. So let me look at how I'm implementing. So let me go through, let's say handle minting, right? So this is the function that's meant to handle when a user wants to mint, right? So what I do is I get the mint amount, right? I get the mint amount from the mint object. and I convert it to big number using the bn library, bn.js, right? Not using the big number because that one is for metas.js, right? Then I do that, then I just call the contract, right? So this is just the contract variable, which I already declared here. You understand? I already declared it here. So basically, I just call it call.mint, which is I'm calling the mint function, which you see that I showed you guys at the end of the contract walkthrough that we have a mint function, right? So I call the mint function. I pass in the address, which is the person I want to send to, right? So this is what the mint, this is what the mint function is accepting, the address of the person that wants to send that's rather the person that wants to meet, right? I pass in the address, then I pass in the mint amount, right? I pass in the mint amount, then I multiply it using this value I set here, right? Now you see the importance of this value I set here, which is basically 10 raised by 18, but in big number representation in bn.js, not in big number. Just take notes, right? So now I multiply it, right? Because you know the way ERC20s work. For us, you know, Solidity don't have, even Cairo doesn't have, cannot represent decimal numbers, right? So for us to be able to interact, work with decimal numbers, we need to bump up the value, right? So that even if you have decimal up to 0.0000 up to 18 places, you can still represent it, right? So that's why we need to bump up this value, right? So that when inside of the contract, it's like normal value that is bumped up by 18, but when we bring it out to a separate environment like JavaScript, you can now divide it by 18 and get your real value, right? So that's why we are multiplying the mint amount by the decimal. Then at the end, we are passing in this 0. So now take note of this, right? This mint function takes, okay, let me go back to this function and show you something. This mint function takes in two arguments, right? The recipient, which is the address, and the amount, right? Now let me go back to app.js. Now see what I did here. So now this is the first variable, right? Then this second value, which is a struct in Cairo, right? It's a struct. And I told you that the way values, the way numbers are represented inside of Cairo implementation or OpenZeppelin's implementation of ERC20 tokens in Cairo is that you have the low and the high. So what I did is I passed in 0 on the low, on the high, which is down, which is the second value. Then I pass in the main number on the low, right, which is the mint amount, which is you can put any value. Then I now multiplied it, I bumped it up, right? I bumped the value up by the decimal, right? So there is like the decimal, I'm meant to actually get the decimal from the contract, but it's a normal phenomenon to use 18. So I just passed it in statically. So in your case, if you like, I think tokens like USDT and USDC, I don't know, but I know there are some tokens. I think it's one of those two. They use 6 as their decimal, right? So if this was the case, then we'll just have to get the value from the contract, then multiply and bump it up that way. But right now we can just, because most tokens are like that, so we just use decimal, right? Decimal multiplied by this, right? So yeah, this is just it, right? So then we now wait for our response, right? We wait for our response. So this is how you call a function. This is how you connect a wallet. This is how you add a contract. Then I want to also show you something I did, which is how I was able to pass, because the way I was getting the value was really not really that helpful. So I had to do a bit of passing. I think I showed it down here. Good. Now, this is a function I just created to be able to get a user balance, right? Because this is an ERC20 token, right? So I need to be able to get user balance, right? So I just created a function to, that's why my balance is showing 0 up there, because I don't have any token right now. But if I bring in the address I used to deploy this, I should have some tokens there. But yeah, basically, okay, this will also show you how to call the normal function, which is similar to how you call mints, right? Or this one just return data, right? So Don't mind my name, the names I used. I just like making things very readable. So yeah, first of all, from the name, I use balance as uinstructs. So this is how it's being returned to me, right? This is how it's being returned to me. It's actually returned to me in big number, right? Okay, no, it's returned as a struct. Then each of these values are big numbers now. So look at what I did next. Then I now went again to get the low. You know, I said you have the low and you have the high, and the low is actually the main value, right? So the high is more like the lower bound. I think that's the way I like to see it. But I think, yeah, Times already gave an explanation on that on the chat, which would help you understand it better. Yeah, so basically, this is the low, value. Then I now convert that value to hex, right? I converted that value to hex, right? Then I actually now converted that value to string. Funny, I don't know. I think I found it hard to just do it. Like the value they were returning was just too, I don't know, it was not really usable. So I had to do all these steps to be able to convert it to something you can understand, which is 0, 1, 2, and stuff like that. So yeah, I had to convert it to hex, convert it to string. This is why I imported big number. So this is why I used that big number from headers.js. So it's not like you need to use it, but this is why I used it here, right? So I now had to convert it again. Okay, I had to convert it to big number again. After converting it to hex, then I now had to convert it to, I now had to divide it. Okay, I now had to divide it by the decimal, which I declared here. You see this number I declared here that I was saying, yeah, I don't know why I did it, so I've forgotten why I did it. So that's why I did it here, because of that function I declared down. Then I put 451. Oh. I said it's a struct because like the value that is being returned it looks more like a struct. So like the way it is being returned, it gives us the low and high. It's not like it's a struct. This is a variable. Yeah, sure, this is a variable. I mean the value that is being returned looks more like a struct. That's why I had to get the balance, get the low. Or it looks more like it's an object in JavaScript. But the way Cairo wants to return it to me is a struct. But that's why I just named it as struct. As into, in fact, just see it as leave this struct, just see it as this U256, which is a struct in Cairo, or rather, sorry, it's a struct in ERC20 token on Cairo, right? So that is how it's being returned. Then lastly, I divided it by the decimal and I converted it to number. So yeah, this is, I think you might run into an error if after the division the value is still not under the range that JavaScript accepts. But yeah, that will likely not be the case. But just to be robust enough, there should be more checking here. But yeah, that's it basically. So yeah, I think that's, let me go through and see. Okay, all these ones are just React state object. I'm just updating to make my buttons and my stuff work as like this. Yeah. So yeah, so basically in this I intend on using this repo for a tutorial. So I really commented it a lot. I commented it a lot. So basically, if you open it, you should understand a lot of things happening, even if you don't understand React, right? So I'm to see if there's any other thing I need to explain here. All this is just React code, but yeah. Okay, let me go through this. Okay,
So, very quick question.
All right.
Not like a question per se. Like I don't know, is there anyone like interested in front end on the call? Maybe I can just like reach out and we can like go through the whole stuff later. Anyone?
Okay. Yeah. Yeah, you heard him. If you're interested in the front end part of things, yeah, just reach out. You can drop your Telegram on the chat so that they can chat you up. But yeah. So at this point, does anyone have any question? I think it has been talking for a while now. So please, if you have any question, just go ahead and ask, and I'll do my best to answer. Okay, these are just some of the utility functions. So this is just the address truncator I talked about, just basic JavaScript stuff. Okay, 10 characters, not 8. So yeah, it's felt to string, string to felt, and yeah. So does anyone have any question? Please go ahead and ask.
For me, I don't have any questions for now, but I might later like message you, get your DM. Sure. You don't
All
mind.
right. There's no problem.
Thanks.
That's okay. So what is the maximum supply and how to calculate it? Okay, so that's not really native. It's not really a Cairo question, but yeah, maximum supply is not it's you can have like if you build a token, right? If you build a token and you want to cap the supply, right? Then people should not be able to mint at all. That way you can make sure that no unit of that token is being created over time, right? So basically you automatically you have a maximum supply, right? But okay, also in terms of Ethereum and stuff, like okay, BTC, right? Based on the calculation and based on the way it is designed, only 21 million Bitcoin each should be created. So that's how they implemented their own way of making sure that it doesn't pass a particular cap. But yeah, it depends on how you want to do it. It's not really calculated. Like it depends. It depends. Like this Bitcoin on now. At the end of this thing, it might not be exactly 21 million, but based on how it's designed, at the end of I think some years time, though no more halving will happen, and yeah, people stop earning fees, and that's how they intend to stop creating new tokens, right? So the maximum supply is really not, it's not really, it doesn't have this one rule. It just depends on how you decide to create your own. Like most ERC tokens, the way they create their own is that you don't have any way to mint. It means that token you created when you created the ERC, the amount of tokens you created when you build the ERC token is the amount of token that will be available throughout the lifetime of the token, and automatically that's your maximum supply. Yeah. Well, yeah, if no one has any question, I would hand over to Paul.
Yeah, it has been an amazing class, right? Yeah. So probably just okay. Okay. Okay, so guys, I talked about thanks for the class, Gospel. And next week we are going to have Alex from Starkware to discuss and teach us about layer 1 to layer 2 messaging bridge, right? So it's actually going to be a quite interesting class. So we're looking forward to everyone to join the class as well. And yeah, so we talked about the assignment, we sent emails about the assignment, and right now we're going to make sure that the feedback forms are sent way earlier, and also every assignment should be checked as well. earlier as well. So, and yeah, thank you for joining today's class, and we hope to see you in the next one. Okay, and if you have further questions, feel free to ask in the group. Okay, always there are people to even most Starkware team are also there to also assist if it's more technical. Okay, yeah, so see you next week. Okay, bye.
Bye, guys.